At this point, you have a lot of tools in your tool belt to help you tackle exponential equations and logarithmic equations. The last thing I want to do in this section is show you some extra examples of equations you may encounter. One of them is going to come from calculus, and then the other two are going to come from other disciplines. You'll be surprised as to how much exponential equations and logarithmic equations pop up in other disciplines. So let's take a look. It says in example 5, solve each equation for the indicated variable. In part A, this is something that you might see in calculus. We're solving for x here. Okay, the equation is 4 times x cubed times e raised to the negative 3x power minus 3x to the 4th times e to the negative 3x is equal to 0. Okay, so what you should realize here is that this equation does involve exponential terms. Like if I look at this piece, e to the negative 3x, the variable x that I'm solving for is in the power or the exponent. And that same term appears right here, okay? So what makes this different than what we've solved previously in this section is the x is also not in the exponent. So you have an x cubed right here and you have an x to the 4th right here. Okay, so you've got a lot of x's floating around and you have to solve for x. Okay, so if you see something like this, what you should do is factor. That's going to be your best bet. You want to solve this one by factoring. Okay, so what we're going to do, okay, is we're going to go to each term. Remember, terms are the pieces separated by addition and subtraction. So you have this term and you have this term. You want to take out what's in common, okay? Remember, you cannot factor unless one side is equal to 0, and we've already got that, okay? So you can go ahead and factor the non-zero side, okay? So what is common to both pieces? Well, we know the e raised to the negative 3x power is common to both terms. Okay, so we're going to factor that out. And is there anything else in common? Well, yes, one of the powers of x, okay, because this has x to a power, this has x to a power. You always want to factor out the smaller power. So we're going to take out x to the 3rd, okay? As far as the constants, we have a 4 and a 3, so we can't factor anything out from there. Okay, so this is what's considered common to both terms. Okay, so we're factoring out x cubed times e raised to the negative 3x power, and we're going to write what's left. Okay, so from the first term, 4, just the 4 is going to be left. Then we have the minus sign, and we've already taken out from the second term the e to the negative 3x, and we've taken out x cubed, so that means there's going to be x to the 1st power left, and also the 3 is going to be left. Okay, so if you factor out x cubed times e to the negative 3x, this is what is left. Okay, the right side is still going to be 0. Okay, so remember how factoring works. Okay, you factor the non-zero side and then you take each factor, set it to 0, and solve. Okay, we end up with 3 factors. Factors are the things that you're multiplying together. We have x cubed, we have e to the negative 3x, and we have 4 minus 3x. Okay, so we have to take each one of these factors, set it to 0, and solve. Okay, so we're going to get x cubed is equal to 0. Then we're going to get e to the negative 3x is equal to 0. And then this is going to, the last one's going to be 4 minus 3x is equal to 0. Okay, so we have 3 equations now that we have to solve for x. Okay, so this first one, x cubed is equal to 0. Okay, take the cube root of both sides. Clearly, x equals 0 is going to be the solution for this particular equation. Okay, so here is one of the solutions. Okay, we don't have to check the answers. This is not logarithmic. There's no logarithms in the original equation. Okay, so we can go ahead and declare that a solution. Okay, on the next one, e to the negative 3x is equal to 0. Okay, what you're going to have to do is you're going to have to take this is exponential at this point, okay? And actually, I don't feel like I have enough room to work it, so I'm going to come over here and write it. Okay, I'll put it in a different color. This is exponential. The x you're trying to solve for here, it's in the exponent. So what you're going to have to do is use a logarithm to get it out. Okay, this is e, so we're going to take the natural log of both sides. Okay, on the right side, or sorry, on the left side, you can bring the power down. Okay, so we're going to get negative 3x times the natural log of e is equal to the natural log of 0, but guess what? This is a big no-no, okay? You cannot take the natural log or any logarithm of 0, okay? So this particular equation has no solution, okay? This does not mean that the original equation has no solution. That just means we have 3 individual equations to solve to get the solution to the original equation. This second minor equation does not produce a solution, okay? All right, so then we've got to go on to the third equation, okay? This is a linear equation, so we just need to isolate x. So we're going to move the 3x over, divide by 3, okay? And this tells us that another solution is x equals 4/3, okay? So here we go, that's it, okay? The original equation has 2 solutions, okay? I'll go ahead and write them up here. I'm going to use this notation of braces where I'm just listing out the solutions. X can be 0, x can be 4/3, okay? 2 solutions to the original equation, okay? Let's try the next equation, okay? We have this equation, it has several variables, okay? This is actually a financial equation, okay? We have A equals P times R over 1 minus 1 plus R raised to the negative n power, okay? P is the principal, the amount of money you might invest in an account. R is the interest rate. A is the account balance. N is basically, it has to do with the time. It has to do with the time that the money is invested, okay? So if you saw an equation like this, we don't have any values for the variable, so we're not going to come up with a numerical answer, but you might have to solve for n here, okay? Just to kind of figure out how much time maybe that your money has to be invested if you did have values for your variables, okay? So let's talk about how we would solve an equation like this. This is going to be exponential because you're looking for n, and it's located in the power here, okay? So think about that, okay? So let's try this, okay? What I'm going to do is, we've seen this in some of our other work in this section. If you're dealing with a fraction, you can get rid of the fraction by multiplying both sides by the denominator. Okay, so what I'm going to do here is I'm going to start by multiplying both sides of this equation by the denominator, which is complicated, okay? But this is what I'm going to do here. This is how I'm going to start my work, okay? So I am going to have on the left side a times the entire denominator, so 1 minus 1 plus r to the negative n. And notice how I put the entire denominator in brackets. It's really complicated, and that a is going to have to get distributed correctly. Okay, so be cognizant of that. If you're multiplying both sides by the denominator here, then what's going to happen on the right side is that this will cancel with this, because this will be in the top and this will be in the bottom, and they will cancel. And so you'll just be left with P times R. Okay, so we continue on. The fraction's gone. Okay, we are solving for n. We need to get n by itself. This is the only instance of n. Okay, so we need to get it by itself. Okay, I am going to proceed by dividing both sides by a. A is multiplied by all this stuff in brackets. Okay, so I'm going to move the a over. So I'm going to divide both sides by a. Okay, so that's going to tell me that 1 minus 1 plus r raised to the negative n power is equal to p times r over a. Okay, I'm still after the guy in yellow. Okay, so now what I'm going to do, okay, you want to work from the outside in. Okay, so this yellow piece is associated with the stuff in parentheses. So let's try to isolate the stuff in parentheses. Okay, I have a positive 1 hanging out here. I'm really kind of adding 1. I'm going to go ahead and subtract it from both sides. Okay, so I'm going to get negative 1 plus r raised to the n power is equal to p times r over a, that quantity minus 1. Okay, all right, we keep going. Now the quantity in parentheses, that's multiplied by negative 1. Okay, the negative is not raised to the power. We're going to get rid of it by dividing by negative 1. Okay, so on the left side, okay, this will cancel. Negative divided by negative will turn positive. You'll get 1 plus r raised to the negative n power. Okay, on the right side, we can divide each quantity by negative 1. So we'll get negative PR over A. Negative 1 divided by negative 1 is positive 1. Okay? All right. We're honing in on the n. So what we will do now, because it's trapped in the exponent, we can go ahead, the parentheses are isolated, so we can go ahead and get the n out of the exponent by taking the logarithm. Okay, doesn't matter which log you use. I'm going to go ahead and use ln. Okay, if I take the logarithm of the left side, I have to do it to the right side. Okay, on the right side, I'm going to rewrite the terms as positive 1 minus PR over A, just so it looks a little cleaner. Okay. All right, so now on the left, I've got the logarithm of something to a power. Okay, so I can bring the power down. Okay, so this is going to give me negative n times the natural log of 1 plus r is equal to the natural log of 1 minus PR over A. Okay, so lo and behold, the n is out of the exponent. Okay, so it's going to be a lot easier to solve for. Okay, all right. Everything, you've got several variables in here. You've got an n, you've got an r, you've got a p, you've got an a. Treat those guys as just as if they were numbers. Okay, what would you do if they were just numbers? Okay, we want the n by itself. So we're going to divide off this logarithmic quantity that we're multiplying by here. So negative n is going to be the natural log of 1 minus p times r over a, okay, divided by this other logarithm, the natural log of 1 plus r. Okay, we're almost there. Okay, we want n, not negative n. Okay, so you need to multiply both sides by negative 1, or divide both sides by negative 1. Okay, so the answer here is going to be that n, negative times negative turns it positive. If you are multiplying by negative 1, okay, remember you're multiplying by negative 1 over 1. You need to multiply either the top or the bottom by negative 1, but not both. Okay, so the final answer is going to be n equals negative natural log of 1 minus p times r over a divided by the natural log of 1 plus r. Okay, so that's how you would solve this financial formula, okay, for the n value. Okay, that way if you did have the p value, the r value, the a value, you could pop those in and get the value of n. Okay, so yes, that was complicated, okay, but you can see that this type of stuff pops up in other disciplines. Okay, all right, let's try part C. Okay, hopefully it's a little easier. This looks like a physics equation. Okay, we have m equals 6 minus 2.5 times the log of the quantity m divided by m0, and we're solving here for m. m and m0 are different quantities. Okay, All right. Also, little m and big M are different quantities. Okay. So we are solving for capital M here. Okay. So essentially, since we're solving for capital M, it is trapped inside of the logarithm. Okay. So we need to isolate the logarithm first. Okay. And then once it's isolated, we can try to free the M. Okay. So what I'm going to do is work my way outside in. So I have a positive 6. I'm going to go ahead and subtract it on both sides. I'm going to get m minus 6 is equal to negative 2.5 times the log of m over m0. Okay. The logarithm is being multiplied by negative 2.5. So I'm going to go ahead and divide by that quantity. Okay, so that is going to give me, let's see, m minus 6 over negative 2.5. These guys will cancel. Okay, so we'll get the log of m over m0. Okay, so that brings us to that point. And the logarithm is now isolated. We're after m. Okay, we have to free it from that logarithm. Okay, so since the logarithm is isolated, we can just apply the arrow definition of a logarithm. Okay, so watch this. So I'm just going to rearrange the sides here. We have the log of m over m0 is equal to m minus 6 over negative 2.5. Okay, do the arrow thing. The base is 10. 10 to this power gives you this quantity. Okay, so let me go back up here. I'm kind of running out of room. But we're going to get that 10 raised to this crazy quantity is equal to m over m0. And the logarithm is gone. Okay, we are after capital M. Okay, so all we have to do now to get rid of the fraction is multiply both sides by m0. Okay, so m is going to be m0 times 10 raised to the exponent will be m minus 6 divided by negative 2.5. Okay, this is the answer. Okay, this is how you would solve that particular equation for capital M. Okay, yes, it's complicated, but again, all of this was to show you that exponentials and logarithms do come up in other disciplines.